Okay, let's break down this Python code step by step. It's about tracking experiments in machine learning, particularly using a tool called MLflow. Imagine MLflow as a notebook where you can record every detail of your experiment, like what model you used, what data you fed it, and how well it performed. This helps you keep track of your experiments and compare their results later. The code starts by defining a function called track_experiment. This function takes three things as input: the name of your experiment, like image classification, the name of the model you trained, like CNN model, and a dictionary of metrics that measure how well your model performed, like accuracy, precision, recall. Inside the function, we first connect to MLflow, which is like opening the notebook. We then check if an experiment with the same name already exists. If it does, we get its ID. Otherwise, we create a new experiment with the given name and get its ID. Next, we start a new run within the experiment. Think of a run as a single attempt to train and evaluate a model. During this run, we log important information. We log the name of the model we used, and then we log all the metrics we calculated, like the accuracy. Finally, we might also save the trained model itself as an artifact in MLflow. This lets us reuse the model later without having to retrain it. Now, let's move on to the main part of the code. It's where we actually train a model and track its performance using the track_experiment function we just defined. We're going to use a simple machine learning model called logistic regression. You can think of it as a model that tries to predict whether something belongs to one category or another, like whether an email is spam or not. First, we load our data, which likely contains information about the things we want to predict. We split this data into two parts, one for training the model and one for testing how well it performs. We use the training data to teach our model the patterns in the data. Once trained, we test the model on the unseen test data to see how well it generalizes to new information. We create a logistic regression model and fit it to the training data. This means we're teaching the model to find the relationship between the features in our data and the target we're trying to predict. Next, we use the trained model to predict the target for the test data and calculate the accuracy. We can then use the track_experiment function to record everything: the experiment name, the model name, and the accuracy we achieved. Finally, the code suggests that you could deploy the model to a platform like Databricks or a model registry. This allows you to use the trained model for real-world predictions. It also highlights that you should monitor the model's performance over time, making sure it continues to perform well as new data becomes available.